Thank
Appreciate it. Good morning, everybody. Thanks for joining us this morning and a beautiful, clear but cold Tuesday morning. Um, we're going to be talking about heat pump water heaters for the energy code. So I'm going to give you a little introduction and kind of our learning objectives today, just to understand some fundamentals or identifying heat pump water heaters, unitary ones. We're going to be keeping it to individual heat pump water heaters. We're not going to be dipping our toe into central systems at all. What do they look like? What are we seeing in the field? And how does the code treat them? And our best way to verify compliance with our energy code. So to take us through that, to achieve those objectives, this is our agenda. Russell's going to take us through identifying heat pump water heaters and talking about the components and kind of the current landscape. And then I'll take it from there and talk about the energy code, how it's treating heat pump water heaters in 2019. It's different than our 2016 code, and we'll talk about compliance, some resources for that, and best practices. So I want to say before we get started, just to reiterate what Sean said, please add some questions in the chat or raise your hand if you have some comments or questions, clarifying questions on anything that Russell and I are presenting. Also, if there's some experience, as we're talking about some situation, if there's experience that you want to share, please do that as well. So hopefully you guys are ready to go. All right. Russell, I'm going to turn it over to you, and you can just let me know how to roll through the slides for you.
Great. Thanks a lot, Amy. So we're going to look into kind of the physical side of the heat pump water heaters to get a sense of really what they are and how they differ mostly from gas water heaters, and how they look. So let's jump into the intros. Next slide. So a heat pump water heater is an electric water heater, and generally they're all storage tanks, and they have both the heat pump side and then sometimes an electric resistant piece in it, and they are very efficient, and they use the similar technology really that AC systems do. So air conditioners, it just runs backwards essentially. And going from the top, it's a very typical looking tank. It doesn't, the very top, it has a fan to move air across it and a compressor typically. These are the standalone units. And it has basic elements, just like most average tanked water heaters. There's a temperature relief valve, an upper and lower thermostat. The hot water comes in from the bottom, and hot water comes in from the top. They're well insulated, like most tanks now, and then there's a condenser that runs to the center of the unit itself. And let's see, next slide. There are a lot of different kinds of heat pump water heaters on the market today. They range from 40 gallons, typically for residential up to 80 gallons. And they have, there's electrical draw of 1.3 kW. There's also sometimes an electric resistant piece in it, and those run a little bit higher. But most of the brands out there, one of them stands out, which is a little different, which is the stand-in. And that one in particular has an indoor unit and an outdoor, much like a split system. And that one typically doesn't have a heating element in it. It's a little more efficient in that way, and runs about 3 kW. Okay, let's see, go on to the next one. Yeah, so let's take a look at the history of where they came from. Heat pump water heaters typically came into the market around the 1970s with the OPEC oil embargo. They were similar to kind of what happened with trying to reduce energy use and trying to save energy. And it was something that we saw that went away, similar to, like you have now there's a lot of solar. Actually, where I am in Berkeley, there's solar thermal storage on the roofs that sort of lasted for about 5 years, maybe a little bit longer, and didn't work. And so these products weren't, they were kind of rushed to the market and didn't do a very good job. Today, they're really different. They, I think, are much, they step forward in the development. They're very user-friendly now. They're very efficient. And they're really designed to move into this low carbon market, eliminating gas appliances, and they're starting to perform very well. The technology has improved considerably, and they're really nicely paired with solar as well. And they also have a certain amount of appeal in certain areas, and we'll kind of go into that a little bit more. It's, they produce cold air, and so they're ideal in certain conditions. Okay, you want to move on to the next slide? Okay, so current funding trends. There's a lot of different programs out there that are offering rebates to these throughout California. And they range from $700 to $1,500 depending on where you are. So there's a lot of either the CCAs, the RENs, and the investor-owned utilities as well. So everyone is either has an incentive program or they're developing one. The other thing is to think about, there is, with SB 1477, through the build program, CEC's low carbon new construction. These technologies are starting to be tested and thought through a little bit. And Amy, you've worked in this. Do you want to add something about this?
Sure. And I think really kind of the takeaway is that I think with this kind of focus on cleaner energy, we're seeing a lot more investment in heat pump technologies and all electric appliances. And so Russell was just mentioning SB 1477 with built-in tech. It should be rolling out in March, and really focus on putting a lot of dollars to transform the market, both in incentives for the technologies, but also training to make sure folks are well supported and have the resources to be successful. And build will be kind of coming out under the CEC a little bit more focused on new construction. And lastly, there's also another program, Self-Generation Incentive Program, SGIP, really been serving PV and battery, but now they're looking at adding heat pump water heaters as a source of thermal storage. And we'll talk about that with mixing valves. But all this is just to say that there's a lot of activity in this space. And if you can't raise your hand today that you've seen a heat pump water heater installed in the field, or had to inspect one yet, or done a plan check on it, you probably will be soon, given kind of this shift.
Yeah, and also there's a lot of studies that are going out. The CEC is working to try to understand how better to get these technologies into homes. Amy's working on a few of these CEC EPIC grants and learning a huge amount about them, and so they're evolving over time. You want to go to the next slide? Okay, so identifying what kind of heat pumps you have, and here there's two main differences. There's the integrated all-in-one system, and then there's a split where there's a tank inside and then a condenser on the outside, much like a typical split AC system for heating and cooling. And The one on the left, the integrated, sits usually in a garage. It can be in an inside closet, and everything's contained within it, much like a gas furnace, gas water heater, sorry. Um, and then what's different about the condenser, the split system, is that the condenser can be on the outside. So it has different applications. There might be a situation where someone didn't had a storage space to put the tank in, but didn't have enough room like in that spots because some of the integrated all-in-one units are fairly tall. Um, and then they also maybe they had a great place to put the condenser outside, and they chose to do that. It's slightly different um, setup, but the same technology as itself. Um, okay, let's go to the next one, and let's look at how these look a little more. Let's see. Um, the very top, and that is where the condenser is. And so you can't see it, but on the side, there's venting essentially. So venting to allow, oh yeah, it's coming up. There we go. Air to be moved through this. And the second one, there's a control panel, much like a tankless water heater. So that's where you can see what's going on with it. It has a very much, that's how you interact with it essentially. Um, there's a large storage tank. I think I said before they typically are larger, which is than 40 gallons even. There's 40, but what we're finding is that 80 gallons is probably a better fit because it just takes a little longer for the energy to recover in that one. So that one's a little bit larger. The electrical connection, again, it's typically 30 amps, 240 volts, dedicated circuit. And again, there's no gas connection here. There's also no flue. Okay, let's go on to the next one. There we go. Okay, so there, in this case, the split system is a little bit shorter, so it doesn't have a top heat pump. The heat pump is separate, and that's outside. There's typically a larger storage tank. There is a control panel as well. This one I think is exterior, and you can mount it on the wall. Again, there's no gas connections. And the condenser is separate from the tank. And these tend to have a slightly smaller, they're 15 amp and dedicated circuit as well. So there's a refrigerant line that goes in from the condenser to the tank, delivering the energy from outside to inside. And they're very similar to a mini split. It's just running water essentially. Well, inside is water, but it's still refrigerant moving between the two, like a mini split. Okay, let's go on. So an electric resistance is very bare bones. They don't have the condenser on the outside or on the top. They're typically 30 amp, 240 volts. Large storage tank, it does take a while for that to heat up. So as a large storage, there's no gas connection and only electric resistant elements usually in there. And there's sometimes a control panel too. Okay, let's see. So a gas storage tank is quite a bit different. So it has a flue at the top. So that's an easy way to recognize that this is a sealed combustion. There's a large storage tank, typically 40 gallons. But then the controls are very simple. So there's usually just a knob. You can't set the control to a specific temperature. It's kind of a range. that you can with the some of the other units, the tanked units that are heat pumps. And let's see, there's a gas connection, and usually there's not a electrical connection, but sometimes there are. So few times there's a fan. Okay, next one. Let's see. So this is a tankless. This can be, this is also vented, either a direct vent outside, or it can be atmospheric. There's no storage tank. It's quite a bit smaller than the heat pump or the tanked furnace, the water heaters. They're wall mounted. They can be wall mounted inside or outside. There is a control panel that is typically either can be set on the inside of the unit, right next to the unit, or somewhere else. And there's a gas connection, and typically there's an electric connection too, because there's fans inside, sort of modulating, trying to cool down the unit as well. So there is usually there's usually always electrical connection. Okay, next slide. So let's compare a little bit the different types of water heaters that are out there. The storage tank has, there's most of the kinds of water heaters out there are storage. Most of them also have electrical connections, so that's pretty typical. And we're really starting to move away from the gas connection, and code and Amy will go into that a little bit more. That's requiring electrical even if you put in a gas water heater. I think that's good for here. Let's go on to the next slide. Okay, so these heat pump water heaters are allowed in the garage, and this might be the best place for a lot of them, and we can go into that a little bit more. It could be an outside closet too, and it can be inside. So there's a wide variety of places it can be. Typically, they have a little bit of noise, so you want to put them in somewhere that's, that you're aware of that, and laundry rooms are a great place for that. Okay, and let's go into, hold on, let me see if this, okay. So what is expected here of the install? Most are 240 volt, 30 amp power supplies, although some are 240 volt and 15 amp, which could be, with panel size being an issue, the 15 amp could be really helpful in that. And coming soon, there's going to be 15 volt, 15 or 20 amp service. And that is going to make a big difference when you're starting to add more electric appliances to have some of that flexibility. The other thing that heat pump water heaters require is ventilation. So you're going to need, and it's similar to a gas storage water heater, you need that, basically that extra air to move throughout the system. You're going to need to think about air venting. You've got all this, it's going to be producing a lot of cold air, and it's very dry air. So there's great applications in some places to, let's say if it's put in the garage that heats up quite a bit in the summertime, you can actually cool that garage down quite a bit. I did see one application where they put it in, so there's more of a, I guess, a commercial situation where they put it in a server room that heats up quite a bit. And so the heat pump water heater sucks all that heat out of the air and then dumps that cold air and sort of modulating that computer room essentially. The vents can be adjusted, so it could be vented outside. It could be in a room that vented to another room. So that cold air is something that could be an advantage, and you should just, people should be aware of how to do that. And the locations, yes, and it's better to be in a hot space, because really what it's doing is moving that heat in that area into the water heater, and it's just transferring heat from that. So it works not as quite as well in a colder climates, in colder situations, because it's not able to really transfer that heat into it as well. There is a condensate line that happens, but it's typical of an AC system. Um, and let's see, there is some considerations about sound. There's some vibrations that sometimes happen. People complain about that. They sometimes get put on like a vibration pad if it's making too much air. And then again, dry, cool air is coming out of it. Okay, let's go on. Okay, so what's included in the plans? You're typically going to have a make and model, first hour rating and capacity, set point and mode, load calcs, thinking about, what's the distribution and location of that water heater. Fairly typical of, normal water heaters in this case. Okay, let's go on. So some things to think about for best practices. Again, ambient temperature in the area. You want it to be ideally in a place that's warmer. You should be thinking about where you're going to vent that cooling. That volume of air is also important. So you should think about if it's going into a closet, how you're going to get that extra air and where is it coming from, and where you're going to dump it in. Plumbing length and air circulation, water circulation. Is this going to be on a recirc line, and what does that mean? And let's see. I think that's about it for that. Again, yeah, it's you really should think about what you're going to do with that cold air and where it's placed, essentially. Amy, do you have anything else you want to add?
The only thing, two things I wanted to add. Just one on the condensate. I'll talk about it again later, but it's water, right? It's just water condensing on the unit and being drained out, unlike AC condensate, right? So it's not condensate from a combustion appliance where you have a different treatment of it. So it's just water. The second one is, the size of the tanks, as folks will be looking at the best size to make sure that they're providing the right service for hot water delivery. And so again, unlike combustion gas fire water heaters, where you just like crank it on and fire it up, and you're kind of accelerating that temperature in that water heater pretty quickly. Heat pump water heaters take longer recovery time, and so Russell is talking about the different units there in terms of 240 30 amp, 240 15 amp, or even we'll start to see 115, 120 volts that are coming on the market for retrofit, probably most applicable to multifamily, like small multifamily retrofit when you have tight panel spaces. But that amperage would also affect recovery time. So just things that people are going to be considering as we see them more of these in the field.
Yeah, and then the other one, thanks, Amy. The other one is the efficiency, which I failed to mention before. It's measured in coefficient of performance, which is different than typical efficiency. So it's not producing the energy from gas or electricity generally. It's mostly transferring that energy from the space around it into the water. So it's extracting the heat. And so it has a COP, which is typically actually, it ranges from 2 to 3. And I think, Amy, it might be higher now, but it's the efficiency of compared to an electric water heater is 2 to 3 times, and for a gas, it's even more than that. I don't know what the efficiency, the COP of many of the heat pumps that you're familiar with is higher than 3, right?
Yeah, it is. And I'll talk about that too in a moment with our federal minimum standards and kind of what we're seeing in the market as well. Let me touch on that again in a moment.
Okay.
Can I take us to the, I said it was energy code at the beginning of this, but I did throw in a quick one slider on the plumbing code,
Okay.
just to make sure you guys are paying attention. The reason why I put this in is just because this came up on a project recently in conversation. So I just want to share it with you guys, make sure you're aware of it, and then we'll actually dig into the energy code. Like I said, it's only one slide. Mainly, I just pulled out here. You can see table 501.1 for the first hour rating in terms of the minimum first hour rating according to the plumbing code that's allowable. So you guys are verifying that, right? In terms of what you're seeing for a heat pump water heater in the field. That first hour rating, right, is based on product listing. If your tank temperature is at 125 degrees. One thing I just want to call out now, I made a mention of thermal storage opportunities for heat pump water heaters. Some of them can go as high as 165 degrees in that tank. Obviously, if you're going to do that set point, it's required to have a mixing valve on it, right? So you can mix it down to 125. But that mixing valve essentially allows you to increase that tank temperature and really increasing the first hour rating. So we recently had a discussion in a small multifamily retrofit where the heat pump water heaters were small. They were 40 gallon and they didn't meet this first hour rating requirements in the chart. But they had a mixing valve and the set point temperature was set at 140. And so with that, we had like it's like a 20, oh, sorry, it's like a 15% increase, right, in available water with that temperature difference. And so the local jurisdiction was like, oh, okay, we're going to accept that because it meets the first hour rating because of the mixing valve and the set point temperature, even though the product listing itself was lower than this chart. So I just wanted to put that out there, maybe something for you all to consider or just think about. But we've run across that situation. So again, hopefully there'll be kind of, we'll have more guidance on that. But yeah, changing that set point increases your first hour rating. And also we're going to see more of that, like I said, in terms of thermal storage. So we can kind of look at leveraging PV systems to warm up our tanks during solar peak hours and reduce kind of our energy use in the evening where we have like a grid peak time. So this is going to be more common. Okay, so that was my one slide on the plumbing code, short and sweet. Now let's go on to the energy code. As we mentioned earlier, based on the examples Russell ran through in terms of what we're talking about, we are talking about unitary systems, like individual systems for low rise. Generally in low rise, what we're going to see is individual systems. We may see kind of a clustered system where somebody could take like an 80-gallon tank and serve like up to 3 units. That's allowable in the code. We're not going to dig into that necessarily. And then also you could see some central systems depending on the apartment configuration for low rise, right, for multifamily. High rise, we're probably rarely going to see the unitary system serving individual units. Most of the time there, we're going to be seeing essential systems just because of the space constraints. And as we were seeing, like heat pump water heaters take up larger space. Any water heater can be installed as long as it meets the efficiency in the CEC's appliance database, and we'll look at that. And kind of most of our requirements and mandatory measures deal with the controls and distribution and pipe installation, and we'll talk about that as well. So I put this up, one, as a reminder, and two, as we kind of talk about the approaches, there's different requirements for performance versus prescriptive. So first off, mandatory measures always must be met. we'll look at a couple of those, but again, my kind of go-to example is your pipe insulation, right? Doesn't matter what you're doing, you're going to make sure you meet the minimum pipe insulation requirements in the code. But after that, then I can make the choice depending on my project scope. I may be choosing the prescriptive path really for additions, alterations, change out, something like that, where I'm hitting everything on that prescriptive list, no flexibility. Or I can pick new performance. I almost called it new construction because that's really what it's used for. I would say 99.5% of our new construction projects use the performance path, so they can have that flexibility of trading different things off depending on the type of project they're doing. So that's just kind of our framework. And I'm going to go into all these details, but in short, one, you can install heat pump water heaters. And in fact, Russell alluded to this, the code actually encourages heat pump water heater installation, and you can replace a gas storage water heater with a heat pump water heater. So this is a shift from 2016 to 2019. The code is encouraging it a couple ways. One, we actually have an all-electric baseline now for new construction, which is different from 2016. So it allows all electric buildings to easier comply with the minimum energy budget allowable. The second is, I'll mention this in a moment, is that we also have a pre-wiring in there if you're not installing a heat pump water heater. So this is your short summary, how 2019 treats heat pump water heaters. 2 bullet points, 1 statement. So mandatory requirements. So I mentioned the pre-wire. All new homes that install a water heater that is either gas or propane must provide capacity for future installation of a heat pump water heater. So the code is saying we want to make future retrofits easier and reduce that capital cost later on. So you have to have a dedicated 125 volt, 20 amp electrical receptacle, but it's got to be connected to the panel with 12243 conductor, right? So I can do a 30 amp 240 volt system later. And it's got to be within 3 feet of the existing water heater, right? So it's accessible and it's convenient. Both ends are labeled. I've got space in the panel, right? It's reserved for future use. And then there's other kind of requirements that would be consistent with typical water heaters, like the venting for future gas tankless and size of gas line, but I'm not focusing on those. And you have to have a condensate drain. So the CEC had put in kind of what does this look like in their blueprint newsletter that you all may take a look at or read every now and then. So you can just see, right? Here's my receptacle. It's all illustrative. You get my close up here. Here's my spare third wire conductor. 3 feet from my water heater. You know, I'm going over. Here's my conduit over to the panel. Here's my third wire, reserved for future 240 use, right? And I've got that space in the panel. So this is my unused conductor because I'm not supplying 240 to this receptacle at this time. So that's what it'll be looking like. So anytime, again, you see a gas or propane water heater, you're going to be looking for capacity at the panel. Can be looking at the electrical schedule if you're doing plan review and field inspection to actually see it installed. So I mentioned this briefly earlier that heat pump water heaters have to hit the minimum efficiency standards in Title 24, and really it makes it easy for us that like all heat pump water heaters on the market meet those minimum efficiency standards. So you can reference a database here. It's also maybe easier to reference the NEA, which is the Northwest Energy Efficiency Alliance list of qualified products, and I'm gonna talk about what that is, but essentially they have been rating and evaluating products on different tiers in terms of meeting specific standards to, I think for 2 reasons. One, allow easier selection by consumers. Oh, this is rated at tier 3. This is what I know I'm getting. And also support references with like programs or code. And we'll talk about how our energy code now references NEA tier 3 pump water heaters. So first, I just want to talk about, we talked about efficiency. So we have the uniform energy factor. It's a slightly it's slightly altered energy factor, which we may be used to for heat pump water heaters. So this, or for water heaters. So this changed in June of 2017. And essentially it just kind of bins water heaters in the same kind of category. So it's a little bit more of an apples to apples comparison versus the energy factor. We can't always say like an EF is going to be lower or higher than a UEF. They vary just depending on the tank size and things of that nature. But I will say right now our federal minimum standard is 2. I don't think you could walk into any retailer right now and find a heat pump water heater on the shelf in the stock room that has a UEF of 2. Generally, we're seeing them, 2.85, 2.75 is probably going to be the minimum you're going to see out there. Most are kind of in the 3s. And then we'll see some like greater than 4 is kind of that range. But that's what we'll be seeing. And then I mentioned the NEA Advanced Water Heater specification. So they have a specification that says this is a performance of a water heater. This is how we're looking at it for these different tiers, to acknowledge anywhere from efficiency to sound to demand response capability. And they have been doing a significant amount of work on heat pump water heaters up in the Northeast, in particular because they have a lot of electric resistance water heaters. And so it's a really super no-brainer switch. And so they've been investing this and doing it a little bit longer than we have in California. So we leverage their experience. You can find the NEA rated heat pump water heaters. They're on their list. You can see, I just pulled out this is really short summary of minimum features for like tier 1, 2, and 3. You can see it's got the minimum UEF there in the column. So as you go up in tiers, they're higher efficiency and they have more features. So this is tier 3 is what we're looking at in our energy code that I will talk about when we get to apply it. This is giving you a sample of the list just to show you, like, it's got, this is tier 3, you can see over there. It's got the product, the model number, volume, etc. So there's all your data. It's constantly being updated, so it's valuable. It's a really valuable resource. They also have tier 1 and tier 2. There's actually nothing in tier 2, and there's some in tier 1. But again, that's all accessible information. Okay. So we've thought about efficiency of water heaters. We'll talk about how tier 1 is applied. Tier 3 is applied in our code. But quickly, let's just look at mandatory insulation. So again, not new. This isn't changing. Actually, insulation actually has changed to align with the plumbing code. So that may also make you all happy that we don't have this variation between the two. But again, pipe insulation is mandatory requirement for all our domestic hot water, and you have tank insulation. So I just pulled it out here as the exact code. We can keep going. So let's talk about, we have got the foundation of mandatory requirements. Let's talk about what is required for heat pump water heaters. So as I mentioned, the performance pathway, right? If I'm doing my model to show compliance with the energy code, which again, really new construction, maybe additions, but rarely. I can do any heat pump water heater in there. Generally, I may even be getting credit for it because it's more efficient than the prescriptive. So in our prescriptive is a UEF of 2. And like I said, we're not seeing those on the market. So I may be seeing some credit there. So sometimes folks can trade off other features by utilizing the heat pump water heater in the performance. If we talk about prescriptive, right? So it, like that pathway, if I'm doing all the requirements over here without that flexibility, there's some other options, but I'm calling out here option 4 and 5, which are related to heat pump water heaters. So 2 things. One, if I do a standard heat pump water heater, right? Maybe it's got a UEF of, I should remember what the tier said, 2.85 2, right, or something like that. It's like a tier 1 or tier 2 standard efficiency. The energy code is saying that's just kind of base efficiency, and so we are requiring you to do additional measures to account for that. So if I do my standard, I then have to do basic compact hot water distribution. I'll show you what that is. It's less than 15 feet in plan review. Uh, so all my fixtures are within 15 feet from my water heater, and I'm doing drain water heat recovery. So I have to do those things, or I can do additional PV, and you can see my PV requirements there are based on climate zone. So that's required if I do a base efficiency heat pump water heater. The other option, and you can see the Energy Commission has structured this in such a way to kind of push people toward higher efficiency selection. If I do a NEA tier 3, right, I'm done. Except in climate zone 1 and 16, where it's a little bit colder, right? And so you're not getting as high efficient operation of the appliance as Russell mentioned earlier. So I can do either PV, additional PV, or I can do compact hot water distribution to kind of balance out that kind of colder climate performance. But you can definitely see the way the CEC is structuring it, like, hey, easy move, select NEA tier rated 3. So that was for new constructions and additions. If I think about alterations, we have 2 different categories we're looking at. One if gas is available, and one if no gas is if no natural gas is available, and one is if natural gas is available. So if I have no natural gas available at my water heater, this is a change in the definition, at the existing water heater location, not to the house is fine, but at that water heater location, then I can install any electric water heater, including a heat pump water heater. All is fair game. If there is gas available, so if I am replacing a natural gas storage water heater, for example, then I have that dichotomy again of a base efficiency water heater. So I can install that, but I'm also going to have to place it on an R10 thermal resistance, non-compressible rigid insulation surface, again, to address the efficiency. And I'm going to have to ensure that there's control for grid integration, right? So it can be leveraged. So it's interoperability there. So that's if I do a base efficiency one. If I do NEA rated tier 3, I'm done, right? I just do that selection, no prescription required. So let's take a look here at kind of documenting compliance and see what this means. And again, feel free to like chime in and say, yeah, that's not what we see, or we do see that, or ask your questions. So these are kind of elements of compliance that we'll look at, right? One, we have the dedicated outlet, right? If it's not, if it is a gas water heater, we're going to see that dedicated. If it is a heat pump water heater, I'm going to be seeing that electrical receptacle appropriate for that specific water heater. I put in 240, but you know, like I said, depending on like if you do the stand in with the split system, you have more flexibility there. I'm going to want to make sure that the installed water heater matches the CF1 arm, the compliance form submitted with the permit and the app. Going to ensure the required prescriptive measures are met. Pipes are insulated. Here's my condensate, right? I've got a condensate line in place for that removal. And again, remember, this is not combustion appliances. There's no combustion products or acids in it, so it can drain into, you know, the sanitary system, the sewer system. It doesn't have to go through an approved treated mechanism. It will have a visible AC disconnect, and you will have seismic bracing. That's typical. Nothing there's changing. So again, just calling out here 2 elements for compliance for the alterations. If there's natural gas, then I have to either have NEA rated tier 3 or meet those additional prescriptive requirements of non-compressible insulation R10 underneath it and demand response. And the natural gas line has to be capped off. If there is no natural gas, any heat pump water heater can be installed. So let's take a minute and look at the forms. Make sure I'm doing all right on time. So the forms are pretty straightforward. They're set up 1, 2, 3. That's the order to go in. That's the order you're going to see them in. Helps us keep things straight in our brains. So on the CF1R, right, you're going to be seeing those all on plan review. Which this made me think I made myself a note to tell you guys to do this in the beginning when I started talking about the plumbing code. If you don't mind, why I'm talking about these forms and how to document them, if you don't mind putting your name, kind of location and role in the chat. Just interested to see, how many folks do we have from the design side? How many folks do we have maybe from building inspection? How many from plan review? Just to get a sense of who you are. That would be awesome. All right, thanks for kicking it off. All right, follow suit, everybody. Thanks, Andrew. So in the CF1Rs, you're going to be getting those in plan review, right? So they're going to be submitted with the permit. They're going to show compliance with the energy code, what's required, and it's going to call out there what water heater is going to be installed. So then you can start thinking about what prescriptive or performance requirements are we looking at. The CF2Rs are only from the installers. So the installer is going to provide documentation for specific measures, and they're going to say, yes, this is what I installed. The 3Rs are from a third party verified from the HERS rater, only for specific measures that require that third party inspection. But they are going to, as a HERS rater, you're going to look at the 1R, they're going to look at the 2R, and they're going to draft a 3R documenting that installation and that it meets the requirements of the energy code. I just want to call out why we're going to talk about some of these measures. There are no specific HERS inspections required specifically for a heat pump water heater. There are HERS measures associated with plumbing in and of itself, but not specific to a heat pump water heater. So I put this up here just to give you a sense of, we talked about some of this stuff is mandatory, right? Depending on what path I go down. So we have requirements for pipe installation. There's minimum requirements. If I'm insulating all of the hot water pipes to get some credit in my compliance software, I'm going to have a HERS inspection verify that, a HERS rater verify that. If I'm doing the basic hot water distribution, that compact system, right, within 15 feet plan view, my water heater is in 15 feet of in plan view from every fixture. That's my basic one. That's going to be verified by plan reviewers at plan check. I can do expanded one. That's going to require HERS. But this we're going to see if I'm not installing that NEA Tier 3 rated heat pump water heater. And then also, I may have to be installing drain water heat recovery there on the right-hand side. These can be used as credit, but you may see them as required depending on the prescriptive pathway that's chosen. So I'm going to go through this kind of quickly just to talk about it once we set up the framework here. For new construction, right, we've got that 1R I've been talking about. It's prepared by the energy consultant. You want to be ensure that it's the same water heater that's called out on the plans, and it matches the CF1R. If it's a NEA rated Tier 3, it's going to show that on the document itself, and it's going to include the make and model. That's going to be required for field inspection documentation, as you see in the next kind of line item there. If they call out a NEA Tier 3, you're going to make sure in the field, like, yes, that is the correct make and model that it's installed. And so this is what it looks like, right? Here's my CF1R, here's my water heater. It's 80 gallon. I've got one of them. You can see it's NEA rated right there. And it's calling out the heat pump brand. It's the A.O. Smith, and it's located in the garage. So those are all things I'm going to confirm when I am in the field. If I'm doing prescriptive, it's the same as the new and additions. It's just a different form, right? So you can see I had the CF1R before perf, right, for performance. Here it's just add. So it's just the naming convention is identifying the type of scope. But again, you're going to make sure that it's matching the water heater called out on that form matches what's in the field and on the plans, right? So both plan review and field inspection. And if I do have, I didn't talk about this before, but this bullet here, if I have any measures that are triggering HERS, like the kind of expanded compact hot water distribution or all pipes insulated or drain water heat recovery, I'm going to want to see those. I'm going to want to get those 2 Rs and 3 Rs before I do the field inspection, the final inspection as a building inspector. So this is just showing you the form looks a little different. This is an interactive form, but I've got my water heating system called out, right? It's 80 gallons, it's electric. I don't have my NEA rated, so it's not a NEA rated. And this is my addition. And here's my 2.9 UEF. And prescriptive, again, similar to additions and new construction, again, but now we're just looking at a CF1R alt, right, for alterations. Again, you're looking for that consistency in the alteration form as well as the plans and carrying that over to the field inspections. Again, these 2 Rs and then those associated 3 Rs for the HERS ones. I just noted those form numbers there just so you can see them because they vary. And again, form should look pretty similar, right? Here's my water heating system, heat pump, and just notice that it's an alteration. Here's a 1R and here's a 2R. This would come from the installer, right? Those 2 Rs to document what was actually installed. So in field verification, as I mentioned, they're going to say the design, the installer is going to fill out the 2R and say this is what was designed and this is what was installed. So these should all match. This should match the 1R, right? This should match what was in section A, right? So my design should match the 1R. My installed should match section A, right? I want to see that consistency. And if I have my HERS inspection, right? So if there is HERS inspection required, again, because they're using expanded compact hot water distribution or all pipes insulated or drain water heat recovery, I'm going to have a 3R and it's going to, I'm going to make sure the design matches the 1R, the installed matches this section C, and then I'm going to have this install here for the field verification from a HERS rater. So I put this up here, you can see it. I'm just going to pull it over quickly. For those of you who have not used, whoops, where'd it go? Oh, I just closed it. Here we go. Energy Code ACE, they have a great wealth of resources. And so this is just the domestic hot water fact sheet. But it just goes through the mandatory requirements, minimum efficiencies, installation requirements, prescriptive requirements. So it's a great reference either for you all doing plan review, building inspection, or also for those that you want to pass across the counter to be like, hey, don't forget this. This is what you got to know. So I just wanted to pull that across. All right. Oh, I'm just taking a look here. So we've got some designers, general contractors, building division supervisors, plumbing designer, good, architect, awesome. A good mix of folks. So interested to hear kind of what you guys think about these. Have you either installed them, inspected them, or run into any issues? So let me get through these kind of best practices, and maybe we can have some questions or conversations. So just overall, kind of regardless of whether it's heat pump water heaters or new construction or additions or alterations, right? You're going to be looking for a CF1R at the permit appropriate to that scope, right? Whether it's performance or addition or alteration. And you're going to want to make sure that there's alignment between that and the plans. One, then you know it's consistent. you're getting what's expected as from a building department standpoint. And two, it also prevents, or reduces potential confusion on the contractor or installer side if those are consistent. So you can also help them ensure that there is that consistency. And then as a building inspector, you can ensure that the installers complete their 2 Rs, HERS raters complete their 3 Rs before you go out for final inspection. That reduces your time. You can leverage that inspection and that information to streamline your efforts in the field, or remote inspections, depending on what you're doing, right? But definitely leverage those and have them prior to going out into the field. And if we think about building inspection, right, you're going to collect those 2 Rs like I mentioned. You're going to confirm the gas configuration, right, because it does matter if there was gas at the existing water heater in the case of alterations, or if it's just to the home. You're going to ensure that the heat pump water heater, regardless of type of project, meets the efficiency requirements, and verify whether it's NEA Tier 3 or not, if it matches that make and model. Which is not something we typically do, and you can't look at, you're going to have to look at the nameplate. And then in addition, you can make sure that the mandatory measures are met, right? Pipe insulation, additional prescriptive measures, depending on what they chose. You don't have to ensure that it meets all the manufacturer's recommendations, but it's definitely something the installer should be looking at, particularly as it comes to like recirc or location or venting or things of that nature. Okay. So now, having gone through all of that, I do want to launch a poll. It's a quick, it's 4 questions. It's super easy, just to see kind of where you're all at. And let's see. Hold on. And if you can answer these 4 questions, but also I'd love to take this time for you guys to ask Russell and I questions. What are we seeing in the field? Or if you can share what you're seeing in the field, or things that make sense, or you may find opportunities, or things you may find challenging with kind of the shift for heat pump water heaters. But while you're thinking of these questions, go ahead and answer those 5 questions. 5 questions in the poll. I'd be interested to hear if any of the designers who've been sizing any or having any projects, or the contractors installed any.
And as a reminder, you also have access to the slides.
All right, you guys, fill out the poll. Get that completed.
Hey, Amy, maybe this is a little more of a kind of fundamental question, but someone asked earlier, how do heat pump water heaters compare to on-demand water heaters? And you touched on that a bit. Is there any other just kind of distinctions or considerations between kind of the gas and electric tankless water heaters, and why someone might opt for a heat pump instead?
Yeah, so kind of why offer a heat pump? A couple of things, and Russell will chime in and add. Russell was talking about efficiencies previously. And so an electric water heater has an efficiency of 1, right? It's not doing conversion of anything. It's taking the electricity into the element, heating the water, 100% efficient. The heat pump water heater, again, is pulling heat out of the air. And so it's utilizing that for heating and minimizing electrical use for heating. And so we were talking about like efficiency factors of a minimum of 2, but generally what we're seeing is like on average 3 and even higher. And so just from an efficiency standpoint, they're incredibly efficient. If we think about natural gas and you think about your standard atmospheric water heater in the majority of California homes, those have an efficiency of like 0.57, 0.62, 0.67. Like that's super inefficient. Plus their combustion appliances. And so depending on where that location is, you can be subject to any kind of inefficiencies or ineffective venting, let's say. So an atmospheric water heater is going to be a lot less efficient. A tankless or gas water heater is about 84% efficient. And then if you look at a condensing water heater, right, that's you always see the kind of 2 PVC pipe because it's condensing, so you don't have the hot double wall B vent piping for it or venting for it. Those are like 92, 94%. So still we're looking at a lower efficiency. If you kind of put a heat pump water heater kind of head to head with a gas water heater, the higher efficiency, and you don't have PV on your roof at all either, it will maybe be about the same to operate because our electricity prices are not kind of in line with our gas prices. But as that starts to change, and it is changing, we see rates more favorable to all electric, that the cost to operate that heat pump water heater is going to go down even more. And we're also mentioning that it pairs super nicely with PV, so that can offset your cost as well. And if you think about like new construction, you have to have PV, a minimum amount of PV on the home anyway. So again, like it's just these things kind of make sense when we think about kind of total home. The other thing I would say, you're just kind of thinking about like tankless versus tank. I think tank also gives you a supply of water if you need it. So in that kind of resiliency emergency side of things, which you wouldn't have that in a tank. Russell, what else would you add to that in terms of thinking about, I guess I'd also add thermal storage, but I'll stop there. What else would you add?
Okay. Yeah, I think that, I mean, there's a lot of the tankless that are out there. And so the difference between a tank and a tankless, generally for the homeowner side is with a tankless, you can get these cold water plugs where you don't have with a tanked water heater. So a heat pump. So that's some of the disadvantages you tend to use. That's a little different with tank and tankless. So I know there's a lot of tankless out there. It's very popular. They tend to use a little more water, and then you have that cold water plug.
Yep. And they are beneficial in terms of, being able to wall mount or install into small places. I think that was kind of one of their main drivers in the forever shower. I think things I'll say about heat pump water heaters too is we just have to think differently about, how we size them in operation. Again, because they do have longer recovery times than a gas water heater.
And Amy, you might want to mention a little bit more about the temperature. So that storage with the mixing valve, I think that's a great combination to kind of use that thermal storage through the peak times.
Yeah. So essentially, you can, if I think about it, and I had some numbers before, but if I have like an 80-gallon water heater and I'm heating it up to 140 degrees, let's just use that number. I'm mixing it down to 125 or 120, right, to deliver to my fixtures, obviously for safety reasons, right? We don't want 140 water at our taps. That 80-gallon water heater has now just become like 134 gallons, right? Because I have 80 gallons of 140, mixing it down. Now I'm increasing my available hot water. So That's also a really valuable thing too, if you think about kind of my space or what space is available to install it. So if you're a contractor and looking at going in of where I can fit one in, and there's limited space, and say I'm only putting in, you know, a 50-gallon, but I can put in that mixing valve, and I can move that 50-gallon. I can essentially create, I think, like 72 or something like that, depending on my set point temperature. In addition, I also mentioned kind of this idea. So that's kind of thermal storage. Then we're also thinking about this idea of load shifting, which is becoming more important, and you'll hear more about, where we want to reduce kind of our energy uses during that grid peak, that 5 to 9 p.m. period. So again, if I think about my water heater as a water battery, right, and I'm heating it up to 140 and I'm not drawing down till later, I just get to reduce my call for energy, for electricity during that grid peak. So that's also a benefit.
Awesome, thank you. That was, I want to just record that and play it back for folks when they ask about heat pump water heaters.
Perfect. Any other questions from folks, or have you, any experience with them yet? We'll be seeing a lot more. Get some folks taking the poll. Some folks can finish up. I can end the poll in a couple minutes.
I'm just linking a few of kind of the rebates, utility rebates, just for an example in the chat. You know, if you want to look through and kind of see what the utilities are offering as well. 3C Ren will be offering our own kind of heat pump water heater rebates, you know, later this year as well through our home energy savings program.
And those programs I mentioned earlier, because since there are some contractors and architects on here, like the tech and the build, those are statewide as well. So it's kind of an interesting landscape of what incentives are available and what you can kind of layer in from multiple sources. So as Sean mentioned, 3C Ren will be having incentives available. And then we also have kind of programs that are at the state level that are incentivizing this. And I would say trainings and support that are coming from multiple avenues, really to set us up for success in this market, and really make sure folks are trained, make sure, like, if you walk into your plumbing distributor that, you know, maybe they even got the heat pump water heater on display, but they're going to be talking to you about it and have it available. So there's a lot of effort, not just from a contractor kind of standpoint, but also distributors and retailers in making sure products are available. So it's all kind of coming down the pike. All right, I'm going to close the poll. We got some of you did that, but I'm going to quickly go through. I just put the things here. We'll see how I did, how Russell and I did, if we did a good job. Just under 2019, a gas storage water heater can be replaced with a heat pump water heater. Yes, that's true. It was even possible under 2016, but y'all may not have seen it because it was like table like 9.1 buried in the code, couldn't find it. And also you just had, there's different efficiencies per climate zone. On the performance base, you couldn't trade it off. So the code kind of has turned a corner here. Condensate drain line for heat pump water heater. Okay, it can be disposed of outside to the sewer, into the sanitary system, whichever, it's just water, right? It's not a corrosive condensate as we see with our condensing furnaces or our condensing water heaters. All new homes must be pre-wired for a 30 amp circuit for a heat pump water heater and a gas line for 200,000 BTU gas tankless. Yes, that is true. So you guys may remember if you've kind of been in this, I think it was like 2008, or it might have been 2005, when the size of the gas line got changed to ensure it accommodated a 200,000 BTU tankless water heater. That was kind of like that kind of push we saw for tankless water heater infrastructure to make it easier to retrofit. And now we've got easier to retrofit for heat pump water heaters as well. Number 4, there are HERS inspections specific to heat pump water heaters. No. There are HERS inspections associated for prescriptive practices that may be required based on your heat pump water heater selection, but not required for the heat pump water heater itself as an appliance. And leading right into number 5, federally minimum compliant water heater, right? The minimum of 2.0 for new construction or additions. Which of the following things may I have to do? See how folks did it. It's kind of an awkward worded question. So I definitely I can either do basic compact hot water distribution and drain water heat recovery, or I can do additional PV. Those are my 2 pathways if I install federally minimum compliant water heater 2.0. I just want to call out, I see some folks selected QII. QII is not required in our code. And not to digress on this, but it is in our kind of prescriptive baseline package. So if you haven't seen a lot of quality insulation installation in the past and new construction, you're probably going to be seeing a lot more of that too, because it's going to be a lot harder to trade off, but it's not associated with water heaters for our heat pump water heaters. All right. Let's see. Sean, should I, maybe what I can do also, have folks fill out the other poll for us right, we're here. Does that sound okay?
That'd be great.
Okay. So this poll is all about kind of your feedback on the training. So I'm going to launch that now. You know, Sean mentioned earlier that, you know, 3C Ren is putting these trainings, a variety of trainings together for different audiences and different topics to really make sure it's comprehensive and the community is supported. So please fill out this poll, but also note that like we can only ask so much, right? In terms of like yes or no, or kind of selecting these things. So if you have specific feedback or requests, like things that like, oh, this was good, or this could have been better, or I'd like to hear more about that, I'd offer you just to reach out to 3C Ren and provide that. We really love to get feedback and understand what we can do to better support you all. So please take a moment and do that feedback on our training, that poll, and we can hang on for any questions or if folks really feel like talking about heat pump water heaters.
Yeah, Amy, do you have, I think there's a few slides I can run through with a evaluation poll is up.
Oh, I'm sorry. Yes.
Yeah, no worries.
My apologies, Sean.
We do have a 3-question survey that'll go out in the follow-up email. Kind of, what'd you love about the course? What'd you like about the course? You know, what could be improved upon? And, you know, what would you like to see in the future? So if you do have any thoughts, you can also share that with us. Just 3 questions. You know, you can share as little, as much, or as you'd like. Yeah, and also please fill out the evaluation poll. But I'll quickly just run through a few notes, kind of upcoming events that you may be interested in connect with this course. Perfect. Next slide. Like I mentioned earlier, this training is offered through our Energy Code Connect program, but we also have 2 other programs, building performance training and home energy savings. Next slide. Perfect. So Energy Code Connect. Energy Code Connect serves kind of all our building professionals, public and private sectors on the Central Coast, for everyone from plans examiners and inspectors, architects and contractors, and for both residential and non-residential. And we have 3 kind of distinct services. First is the Energy Code Coach, which you can access online, over the phone, and ask your code questions. So, we do have kind of another heat pump water heater course coming up for private sector, for architects and contractors. You kind of have this conversation with a different crowd. But if you're kind of walking away from today's training and maybe something comes up in the field, you're like, maybe you don't see it in the slides, go ask the Energy Code Coach. You can, I'll put a link in the chat, and that's a great resource for you to also continue this conversation, and ask questions and learn more. So check out the forum online. You can also call, and Amy and Russell, help out with that service as well, and can field your questions outside of this training too. And then, like I mentioned, we'll have continued trainings each month, and kind of electrification and heat pumps are kind of a theme we're running through in winter. So you will see a few other courses kind of on heat pumps, like I mentioned, for the private sector, for all electric Z&E, heat pumps and other kind of small electric appliances, residential and commercial projects. And we also have a course more broadly on just electrification and the 2019 code itself. So the example of some of our trainings coming up, and all leading to kind of our winter regional forum, which will focus primarily on heat pump water heaters as kind of a point of conversation in electrification. So I'd highly recommend that if you'd like to continue this conversation yourself. That'll dive into kind of the market on the Central Coast for heat pump water heaters. And we're some of my colleagues are working really hard to kind of take inventory of what that market is and what that opportunity presents to building professionals in terms of business and funding available. So I think that's going to be a great event and would encourage you to join. But simply put, we want to make the energy code a little more easier for you to work with and understand. So next slide. Perfect. Building for performance training, also another kind of training focused program of ours, although we get to be a little more broad with this, focusing on kind of high performance building as a whole, not just on the code. We really want to serve, architects, contractors, but those who haven't been touched by some of our other programs. So some hard to reach workers, underserved, and we get to do a little more with this, from technical skills also to soft skills like sales and marketing. And we really want to help the industry as it's evolving, kind of stay current, whether you're someone new coming in the field or an existing professional kind of looking to buff up your knowledge. Perfect. Next slide. Again, just linked the code coach in the chat. You can check out our website. All of the information is on there, but highly encourage you to reach out if you have any questions and attend any of our other events. Next slide. And yeah, someone asked, the slides will be available. Send them out shortly, get them out to you today, along with a recording, and check out the course calendar for some of our upcoming events as well. And if anyone did request or leave their ICC number, we'll get you those learning units as well. Perfect. With that, kind of just want to provide one more opportunity for questions or any final words from Amy or Russell. But I do thank you all for spending a little bit of your morning with us today.
Hey, this is Andrew Goodwin. I just wanted to clarify one thing that you touched on briefly. We've been speccing heat pump water heaters in a lot of our projects. You know, as the architect, I get a call from a contractor, you know, almost on every single project from a plumbing contractor saying, why do I have to do this? I don't understand this. Is it just a good opportunity there to point them in your direction to educate them? I mean, how do we take care of this lack of understanding? And I guess there's no willingness to do it either. They're looking for ways out because they see it being too expensive or just too unknown. Like where do we send them? Just to you guys?
Sean, I'll let you. Did you want to chime in on kind of overall 3C REN resources, or do you want? I can respond a little bit just in terms of the situation, but.
Yeah, it looks like our program manager, Jordan, might have an answer for you too, but Amy, can encourage you to jump in as well.
All right, Jordan, I'm going to say, so then you can also chime in and correct or modify. Andrew, I think the conversations you're having are kind of what I would say is pretty typical right now. You know, we're seeing kind of pushback from plumbers because they don't want to do the whole job, or it's new, it's different. The electrician needs to be called in. There's more coordination. So one, I think, and this is why I'll defer to kind of Jordan and Sean to kind of really dive into what 3C REN is doing in terms of like providing more information and education. We're kind of in the middle of it here, and I think the challenge is like there's a shift that's happening, and I think it's hard to say to folks, look at that shift and get yourself prepared for it because this is going to be more common. Right? You're kind of asking them to look ahead. So I would say I think 3C REN between like their building performance training and the forum coming up in March, which is focused on heat pump water heaters, is really looking to kind of build kind of base knowledge there and kind of what that opportunity is in the market. We're mentioning so many kind of incentives and training things that are available or becoming available that can help drive down that cost. I think, and it, you know, when we work with different design teams, it's like you find somebody who's like, oh, I got it. Like you may be the got it guy, Andrew, like you got it and you're speccing this. And then, you know, you're also a voice to help kind of provide that benefit or kind of educate to other players on the project team. I think are you doing mostly new construction?
Yeah, I mean, it's most of the new construction projects, that's for sure.
I mean, to me, I guess from a new construction standpoint, I understand that, you know, they may be saying it's a different kind of process, right, or install, but just from an overall benefit, if we're looking at PV, you know, already on the roof, again, kind of that holistic perspective, the benefit to that occupant is great, right? With new construction. And so
and I think it's not an issue per se of like convincing them that it's a good idea. It's just the contractors on these projects either have not been directed to go and ask the people that are doing it, and they're going to the good old boys that don't know how to do it. And it's causing a lot of hiccups in construction because then you get infighting and people saying, well, we don't need to do this. Let's just switch to the old system and let's bring a gas line and let's do this and that. And we'll just redo the Title 24. And it's a misconception. And I'm looking for like the resource of point some of these contractors to a list and say, go talk to these subs. These subs know what to do. At least bid to them too, because I mean, we work across the state of California. It is not just in the 3 counties. Like, you're seeing it everywhere.
Yeah. In that, I don't know, in terms of a contractor list, I know at least in Northern California, 9-county Bay Area, because of some of the rebates that are available, the Bay Ren program has put out a list of contractors that are like, these guys know heat pump water heaters. They're willing to install it. But there's still a number of contractors that don't. I mean, I've worked with folks who've had a broken water heater and called the plumber and he's like, I don't know what you're talking about. Or it doesn't work well, right? But let me pause there. Jordan, I'm just gonna, if you have some kind of resources or perspectives to share from your end.
All right, can you hear me now? Yeah. Andrew, sorry, I'm having all types of, I already got booted off of this call once, so this is strike 2 on my part. So I know we're over time, but I will say, to answer your first question, yes, please direct them to us. We're happy to find avenues and provide training and whatever types of resources we can find. We are working closely on both the supply side as well as the demand side on trying to figure out this problem, at least for the Tri-County region. We're talking with Ream, A.O. Smith, Bradford White, the manufacturers, and then trying to trickle downward into the actual supply chain to really get these units available to folks. So as well as the training. So if you have contractors and contractors, and you kind of nailed it on the head, are a little bit challenging, and it's something that we're really trying to focus on in 2021 and beyond, in terms of training, in terms of showing the benefits of this type of construction, in terms of showing the cost or the value to their business, because to quote Bob Dylan, the times they are changing, right? This is the path the state is going eventually. So pretty soon they're going to need to adapt or die, and the reality is it's coming quickly. So please send them to us. We are happy to support you in whatever way, especially if you are speccing heat pump water heaters in the majority of your projects. That's great, first of all. But we're poised to provide any type of training that's needed, whether it's a broader training across the territory, or heck, even something a little bit more specialized. So let's continue the conversation, and we're here to support.
Thank you. And just to be kind of the encouraging person on the call, like, because I know that was kind of a downer conversation that contractors aren't doing things, but over the past 3 months, we've had probably 50 new home requests, and I would say 45 of them are saying, let's go all electric. So there's a very, very good move happening with the people that are spending money to build new homes and new projects. So I think it's really great that you guys are doing this. That's why I'm here. But the contractors that don't have the time to be on these calls, and the contractors that are out there doing the work right now, need to hear this and to be educated, because that's the weak link, in my opinion. I think all of us in the beginning stages of a project can kind of see the vision, because we're already future thinking. But those that are on the ground and responding, and Don Moore and his crew and everybody that's trying to help keep things together and compliant, are facing some big challenges.
Yeah.
And to Don's comment in the chat, we're definitely a little limited right now providing these trainings online, but it's a big part of our plan to be in the field at some of these supply houses and warehouses, and offer this training too, and make it accessible. So I think at some point that's a piece of the puzzle too that we're working on as well. But awesome. Thank you so much for this conversation. I think, we need to hear that feedback too. It's really helpful to us, and to help put this training in context too. But yeah, with that, I think we're over time. We're done. So I want to thank you, Amy and Russell, so much for sharing today, and thank you for helping us have a conversation.
Thank
Yeah,
you,
it was
and
great.
thank you all for joining.
Yeah, it was wonderful.
Awesome.
Thanks.
You
Have a good day, everybody.
Have a good day.
Bye-bye.